This is the first of our videos for Unit 2, and it's about speed and velocity. You probably want to take some notes on this so that you can use them on the quiz at the end of the video. This video has a lot of objectives. You're going to be able to explain the difference between a lot of things, because in physics we use terms differently than kind of walking around people. So you're going to be able to explain the difference between displacement and distance, the difference between average speed and instantaneous speed, and the difference between speed and velocity, which you probably thought were the same thing. We're going to learn two new formulas, one for average speed and one for velocity. And finally, we're going to talk about how you can change velocity. Let's get started. Now, I'm sure you've all heard of speed before, thinking about how fast somebody runs or how fast a car goes. And when we think about speed in our terms of American measurements, what we've been brought up with, we think of miles per hour. Well, in science, we use the metric system for measuring. So, the units that we're going to be typically using are going to be kilometers per hour or meters per second. And even though these seem a little bit different, both of the systems have a distance, miles, kilometers, or meters, divided by an amount of time, hours, or seconds. And this is going to come in handy in just a few minutes. So in this class, we're going to use both kilometers per hour and meters per second, but mostly meters per second for the experiments that we do. When you're measuring the speed of a car, we talk about miles per hour, but in the metric system, that's one case where you'd want to use kilometers per hour. When you're talking about a person running, typically you're going to talk about meters per second. And then a type of experiments we're going to be doing in this class, for example, using some carts or toy cars and rams, we're going to be measuring in meters per second as well. So let's take a look at a formal definition for speed. When we're talking about speed, we're talking about the change in distance, something like miles, kilometers, or meters, in time, like hours or seconds. Now, when we're talking about speed, it doesn't matter which direction something is going in. And direction is going to become important in just a minute. The variable or symbol that we use for speed is like the letter V, and units, like we talked about, we're going to use meters per second a lot, like a distance over a time. So, how we'd write this as a formula is that you'd have the average speed equals the distance over the time. How you'd use this instead of writing it out in words, this didn't come out very well, is you'd write V for speed equals d for distance over time. Now in physics, it's important from now on that every time you write a number, it should have a unit after it. So for example, distance is going to be in something like meters most of the time. Time is going to be in seconds most of the time. And then that makes speed in meters per second. So if you forget about that, think about miles per hour. This is kind of like miles per hour, except meters is the distance and seconds is the time. So this is the formula. In this class, you're never going to have to memorize formulas, but instead, I'm going to usually give them to you. This one, though, you probably want to have in your notes. So you may have noticed that that formula was for average speed. And I want to take a minute to talk about the difference between average speed and instantaneous speed. Imagine that you're taking a trip in your car, and that trip is going to take some whole period of time. And how you figure out your average speed is you take the total distance that you went on the trip, and you divide it by the time on the trip. But as you're going on the trip, you're probably going to hit some stop signs and some stop lights, and you're going to hit different speed zones where you're going to be going different speeds. So, at any one moment on your trip, your speed could change. And the speed at any one moment is called the instantaneous speed. So, do you understand the difference? Average speed is the speed over the whole trip, and instantaneous speed is the speed at any one moment during the trip. So, instantaneous speed can change quite a bit during a trip. Let's use that formula that we just had to do a couple of problems. Remember, average speed, is equal to distance over time. If we look at this problem, it's giving us a distance of 45 kilometers, and it's telling us that the time is 3 hours. And it's saying, what's the average speed? So here's our distance, here's our time, and we don't know the average speed. So we would just set it up like this. 45 divided by 3 is 15, and remember, we have to put our units, kilometers per hour. Let's try another one. Now I'm working through these problems pretty fast, so if it's going too fast, feel free to pause it or slow down. This one says, car 2 travels at 30 kilometers per hour, and that's a speed, for 2.35 hours, and that's a time. What distance does it go? So we don't know d. Let's write our formula down. And let's plug in what we know. 30 kilometers per hour is the speed. We don't know the distance, but we know that the time is 2.35 hours. To clear that 2.35 from the bottom, we have to multiply both sides by 2.35. Which cancels 2.35 on this side. And when we multiply 2.35 times 30, we get 70.5. Now remember, this is 2.35 hours. So these hours will cancel each other out, and what we'll have left is a distance, and we want to make sure to put our units with the distance, so that's going to be 70.5 kilometers. Let's look at this last one. Car number 3 travels 325 kilometers. That's a distance at an average speed of 80 kilometers per hour. How much time did it take? So what we're trying to find here is time, and it gives us average speed and distance. Let's use our formula. Plug in what we know. And see what we can do. We need to get that t by itself. So to do that, first we'll have to multiply both sides by t. And I'm going to keep the units off, just to make this a little more simple. This gives us 80t equals 325. Then we have to divide both sides by 80, which will cancel out the 80 over here and leave us with t, and on the other side give us 4.06. Now it's a common mistake to just leave it like this, but remember, now what we have to do is make sure that we include units. In this problem, what are the units for time? Well, here they are right here. Hours. So, let's put those hours in there. So on today's problem set, and on your labs, you'll be doing plenty of problems like this. So if you don't feel like you've mastered it just by looking at these 3 examples, don't worry. You'll get plenty of time to ask questions and plenty of time to practice. Now I want to introduce a couple of other terms, and those terms are distance and displacement. Now don't get intimidated by the words, because what they mean is something that's pretty easy. So distance you've probably heard of before, and that's when you travel, that's how far you go. And it depends on the path that you take as the distance that you travel. Now displacement is different because it's talking about where do you finish compared to when you start. In the case of displacement, the path is not important. Let me give you an example. Suppose that you travel 100 miles this way, and then you travel 100 miles back. You're taking a car trip someplace, to Wisconsin or something like that. Now, the total distance that you traveled would be 200 miles. But your displacement, since you started here and you finished at the same spot, your displacement would actually be 0 miles. This is going to be important when we talk about the difference between speed and velocity. Let's do a quick example. So here we have an example where Carla walks 4 kilometers to the east and then turns around and walks 1 kilometer to the west. So what's Carla's total distance traveled? Well, first she walked 4 kilometers, and then she turned around and walked another kilometer. So her total distance was 5 kilometers. Now to think about displacement, we need to think about where Carla started. Then she went 4 kilometers east, and she went back 1 kilometer west. And where she ended up at was 3 kilometers from where she started. Now what's important with displacement is that we need to include something to show us direction. So 3 kilometers. Since she went 4 kilometers east and 1 kilometer back west, her displacement is 3 kilometers east. Now, we're going to use distance and displacement to explain the difference between speed and velocity. Now, our definition for speed said that speed was the rate of change of distance per time. Now, with velocity, it's the rate of change in displacement per time. So, what we're dealing with is a lot of the same thing, and even the formula looks the same, except what the letters stand for are different things. So in this case, this V stands for velocity, this D stands for displacement, and the T still stands for time. Our units for everything is still going to stay the same. A good example of a unit for displacement would be meters, and time would be seconds, which would give us the units for velocity in meters per second. But a lot of times with velocity, we need to include a direction, because direction is important. Is your displacement going to be to 3 kilometers east or 3 kilometers west? So just to emphasize the point again, speed is a change in distance over time, and velocity is a change in displacement over time. Since direction doesn't matter with speed, the numbers that we get for speed are always going to be positive. The numbers that we get for velocity, since direction is important, we're going to see that velocity can actually be negative or have a direction. So in our example, we found displacement was to the east, but we can express the same thing using a positive number for the east and a negative number for the west. As we move along in this unit, we're going to see examples of that, but not quite yet. Let's revisit our example with Carla. Remember, she walked 4 kilometers to the east and then 1 kilometer back to the west. This means that her total distance, since she walked 4 kilometers and then 1 kilometer, was 5 kilometers. But her displacement, since she kind of canceled out one of her kilometers to the east with the 1 kilometer to the west, her displacement is going to be 3 kilometers. So this is going to affect her speed, and hopefully you're starting to see it. So it says if Carla completes this walk in 2.5 hours, what's her average speed? Well, remember, we have this formula. We're given the distance of 5 kilometers and a time of 2.5 hours. So her average speed is going to be 2 kilometers per hour. Her velocity, we use the formula that looks the same, except now D stands for displacement, which is 3 kilometers. And she did the same journey in 2.5 hours. So if you run this through your calculator, you get 1.2 kilometers per hour. If you want, you can leave it like this as a positive number, or you can say 1.2 kilometers per hour east. The last thing that I want to do is relate speed and velocity to your car. Remember when we talked about average speed, which is the speed during your whole trip, versus instantaneous speed, which is the speed at any given moment? When you're in your car, you can always tell your instantaneous speed just by looking at your speedometer, and it tells you how fast are you going at that given moment. Your car won't tell you what's your average speed. So that's something that you have to calculate by figuring out the total distance that you drove and the total time that you drove. Distance is shown by your odometer, which is that thing that keeps track of how many miles you've driven for the life of the car. And remember, you have a trip odometer that'll show from when you press the button until that moment that you're interested in looking at. In your car, you can change your speed with your gas pedal by increasing your speed, or your brake by decreasing your speed. Velocity is a little bit different because velocity involves direction. So your car doesn't really show you your velocity, and it doesn't show you your displacement, like how far you are away from your house or something like that. And what you would use to change the velocity with your car is that you can change your velocity with the gas pedal. You can use the brake too, just like speed. But since velocity depends on direction, you can also use your steering wheel, and that's a change in your velocity. So that's it. I know this is kind of a confusing introduction to everything, but we're going to be working with it a lot, starting with our lab, Physics Olympics, and the problem set. Get some practice, ask some questions, and I think you're going to find that this isn't too bad.